Why is blood red? It sounds like a simple question, but the answer is actually a chain of tiny physical and chemical effects happening inside your body every second. Blood isn't just a liquid, it's a transport system constantly moving through arteries, veins, and capillaries, carrying oxygen, nutrients, and waste. But the color you see isn't from the liquid itself. It comes from something microscopic riding inside it: red blood cells. Inside those cells is a molecule called hemoglobin. This is the real reason blood has color at all. Hemoglobin is designed to bind with oxygen in your lungs and release it in tissues that need it. It's basically a molecular delivery system. But hemoglobin has a second job it wasn't designed for. In any intentional sense, it interacts with light in a very specific way. It contains iron. And iron changes how light is absorbed and reflected depending on whether it is carrying oxygen or not. When oxygen binds to hemoglobin, the structure shifts slightly. That small structural change alters how the molecule interacts with light. It reflects more wavelengths from the red part of the spectrum, which is why oxygen-rich blood appears bright red. This is the blood pumping straight from your lungs through your arteries. But once that oxygen is delivered to your tissues, hemoglobin changes again. It releases oxygen and returns to a deoxygenated state. Now it absorbs more light and reflects less bright red wavelengths, making the blood appear darker, deep red or maroon. That's the blood flowing back through your veins. So blood actually changes shade depending on how much oxygen it's carrying. It's not static. But this leads to a bigger question people often get wrong. If oxygen-rich blood is bright red and oxygen-poor blood is dark red, why do veins sometimes look blue under the skin? The answer is, they don't actually turn blue. That blue appearance is an optical illusion caused by how light penetrates skin, scatters through tissue, and reflects back to your eyes. Skin absorbs and filters light in a way that makes deeper vessels appear bluish, even though the blood inside is still red. If you could look directly at veins without skin, you would never see blue blood in a healthy human. Not ever. So the entire blue blood idea is a trick your visual system plays on you. At a deeper level, the red color itself comes from something even more fundamental: how molecules interact with light. Hemoglobin absorbs certain wavelengths, especially in the green-blue range, and reflects the longer red wavelengths back to your eyes. That's basic physics layered on top of biology. And this is why blood isn't just red by coincidence. It's red because iron-based oxygen transport chemistry naturally produces that optical outcome in living systems like ours. Even more interesting is how consistent this is across humans. Every person, regardless of background, has essentially the same hemoglobin system. That means the same color logic applies everywhere in the human body. So when you see blood, what you're actually seeing is a real-time indicator of oxygen chemistry in action. Microscopic protein structures, iron atoms, and light physics all interacting in a way that keeps you alive. And that simple red color is basically a visible side effect of one of the most critical survival systems in biology: